If you've understood all the steps before, adding fractions is quite a simple process. But we have to be mindful of what it is that we're doing so that we don't make the simple mistakes. The first thing to note is that you can't add two fractions together if the denominators are different. And to see why, it's usually best just to look at an example. So here I've got a pictorial representation. I've got a half and a quarter, and I've added the areas together and I've gotten this shape. But if we look at this shape, we can't name it as a fraction because the parts are different sizes. It's definitely not 2/3 because 2/3 would be more of the shape shaded. And it's not 2/6 or lots of other different wonderful versions of answers I see. What we really need to do is to make the parts in this shape equally sized. And the easiest way to do that is to draw a line across here and make quarters, and then you can see that there's 3/4 shaded. And thus a half plus a quarter is 3/4, and it actually is. So here it is here. So what I did was I took this shape here and I made it into quarters to make it easy to add. Now you could think about multiplying by 2 on 2 and that would give you 2/4, and that's the same as a half. Or you could just think, oh, I drew the line over there and counted the shaded parts. Now once I've got 2/4 plus a quarter, it's easy to see that it's 3/4. Now with arithmetic, we have to make sure that we do the same process. So make sure that whenever we're adding fractions, the denominators are exactly the same, or we'll end up with this problem here of an answer that makes no sense. So the logic's quite simple. To add two fractions with the same denominator, just add the numerators together. And that's effectively what we did here. Took the numerators, added them because the denominators were the same. To add two fractions with different denominators, find equivalent fractions first, which is what we did. Again, we started with a half, but adding them together made no sense using arithmetic until we'd made quarters. So we made quarters, and that enabled us to add the numerators as before. So here are some cases. We have a quarter plus 5/4. The denominators are the same, add the numerators. We end up with 6/4. We have a third and we want to add a sixth. Well, thirds and sixths can't be added together. We need to make them all either thirds or sixths. It's easier, well, in this case we're going to make them into sixths by multiplying by 2 on 2. 3 times 2 will give me 6. Have to remember that 1 times 2 is 2 to preserve the proportion. So I'll end up with 2/6 plus another sixth will give me 3/6. Easy enough. I've got the question here, can it be simplified? Well, if you drew 3/6, you'd see it's a half. So we know that we can divide this by 3 and divide that by 3, and you'll end up with a nicer fraction. Well, at least a simplified fraction. So here's our last case. We have 2/3 plus a quarter. Thirds, 3 and 4 are different denominators. We need to make them the same. The lowest common multiple of 3 and 4 is 12. I can show that here if you like. 3 and 4, 3, 6, 9, 12, 4, 8, 12. The first common number is 12. Right, so if we're going to make the denominators 12, 2/3 is going to have to be multiplied by 4 on 4. 3 4s will give me 12, 2 4s will give me 8. There it is there. A quarter will need to be multiplied by 3 on 3. 4 times 3 will give me 12. 1 times 3 will give me 3. We now have like denominators. We can add the numerators. 11 over 12 is the sum of 2/3 and a quarter. As soon as the denominators are the same, solving it is easy. It's just that trick of understanding equivalent fractions. So let's do some more examples just to make sure. A quarter times a fifth. The lowest common multiple of 4 and 5 is 20. 4 times 5 will give me 20. Multiply the numerator by the same to keep the proportion. 5 times 4 is 20. Multiply the numerator to keep the same proportion. That will give us 5 on 20 plus 4 on 20, which will give us 9 on 20. 7 on 8 and 3 on 2. This is a bit different. If we look here to find the lowest common multiple, 8, 16, 24, 2, 4, 6, 8, 10. You can see here that the lowest common multiple is 8. So given that, we don't have to do anything to 7 on 8. We can just write it, but we do have to find an equivalent fraction for 3 on 2 in terms of eighths. So we need to multiply that by 4 on 4 2 times 4 will give me 8, 3 times 4 will give me 12, adding 7 eighths to 12 eighths will give me 19 eighths. Now we could convert this to a mixed numeral, but it's not necessary, especially where we've already been given an improper fraction to start with. It also works for subtraction. Same deal. Find equivalent fractions, then subtract the numerators. 7 eighths, eighths and thirds. They'll have a lowest common multiple of 24. So 7 on 8 times 3 on 3. 8 threes are 24, 7 threes are 21. That gives us this fraction. 2 thirds times 8 on 8. 3 eighths gives me 24. 2 eighths gives me 16. 21 takes 16 gives me 5. If we subtract 7 eighths from, if we subtract 2 thirds from 7 eighths, we'll end up with 5 over 24. Similarly, if we have 8 tenths and we take away 2 fifths, the lowest common multiple of 10 and 5 is 10. We can leave the 8 over 10 as it is. If we multiply 5 by 2, that'll give us tenths. That's down here. Remember to do the numerators as well. So 2 fifths is the same as 4 tenths. Subtract 4 from 8, leaves you with 4 tenths. And if we want to simplify it, we could divide the numerator and denominator by 2, which would give me 2 over 5. That, being able to do that is what stumps many, many adults. But when you get to the bottom of it, it's quite a simple process, as long as you know your tables and you've practiced it. So there you go. Thank you, everyone.